So how can we take advantage of Eclipse attacks to perform double spending? So just a recap, what is double spending? It's not really spending money in like twice. It's not double. It's actually spending money potentially n times. So a technically correct, more correct word would actually be kind of like n spending, right? If you can spend it twice, why wouldn't you spend it n times? So we have here this example where we have an adversary, right? This is our adversary, this is our victim, and we have a legitimate transaction. This is a legitimate transaction that pays the vendor or the victim, and we have a double spend transaction that pays the adversary. So what the adversary wants to do is he wants to send two transactions, right? A legitimate transaction and a double spend transaction to the network, and the adversary will hope that a double spend transaction is the one that gets confirmed and the legitimate transaction is accepted by the victim. Now, if the victim says, okay, I accept the payment before the network is actually confirming the legitimate transaction, the victim might be defrauded, and that's also what's called like a zero confirmation transaction. So zero confirmation transaction means it has zero block confirmation, right? No block confirmation. And this is something, if you receive a blockchain transaction, certainly something that you want to avoid. Now, the question is, how many blocks will you want to wait before you accept a particular transaction? And this heavily depends on the blockchain that you're looking at, and it also depends on the value. So there might be values like people might tell you we have to wait 6 blocks. Some people tell you have to wait 30 plus blocks. So it really depends. We can quantify actually the number of blocks that you should wait, depending on the value of the transaction value. But this is just the overall intuition of what double spending is. Now, given that, how can we perform an Eclipse attack? Given this particular double spending method. So yeah, it's always important. The victim or the vendor, he probably will exchange the goods and services before waiting for this confirmation, before waiting that this is actually confirmed. So that's why it's called a zero confirmation. So if the honest network will accept the double spend transaction, then the legitimate transaction is invalidated, and the double spend transaction is deemed the right one, right? At least by the network, not by the victim. So we can perform a double spending attack given an Eclipse attack, and this is quite reliable. So if we assume that the vendor accepts a Zero-conf transaction, which he should never do, but let's assume he does, we can perform an Eclipse attack here. So please pause the video for a second and think of how you would perform an Eclipse attack. What are the steps, step by step, that you would do to defraud a vendor if you can blind the vendor from a particular transaction? So if you can make it not see a particular transaction. Okay, let's go through it together. So what the adversary can do is he can basically blind the vendor with a double spend transaction. So do you recall how he does that? What does he need to send to the vendor to do so? It's the hash, right? It's the inventory message or the hash of this double spend transaction. So then the vendor will basically wait for the adversary to send this transaction. Next, the adversary sends the double spend transaction to the Bitcoin network. So what happens next? The Bitcoin network will advertise the double spend transaction to the vendor. However, here the victim or the vendor is already blinded. So he will not request this data from the Bitcoin network. Remember, transaction propagation in Bitcoin is a first in, first out queue with a timeout. So then the adversary will send a legitimate transaction to the vendor, and the vendor will say, thank you, I accept that transaction, because he accepts zero confirmation transactions, and the vendor will even forward the legitimate transaction to the Bitcoin network, but the Bitcoin network will not accept it because it conflicts with the double spend transaction, and here we go, right? That's a very simple double spend of zero confirmation transactions. Now, how can we extend this to a double spend of a one confirmation transaction? So it's a bit more elaborate, but let's go through it step by step very carefully. So we assume we have a vendor, right? The vendor only accepts a transaction and will deliver the goods if the payment transaction is confirmed in one block only. So he's fine with the security of one block. We assume that we can collaborate or basically work with some weak miner somehow. Whether that's a weak miner or not probably doesn't matter too much. But let's just look here at the high level for now. We assume again we have a Bitcoin network that is mining as well, and on the left side we have an adversary. So we denote by XL here. This is the legitimate transaction, and by XD we call it the double spend attempt or the double spend transaction. So D is double spend, L stands for legitimate, right? Here you have TD, double spend, BD is the block that double spends, etc. So now let's go step by step. So we start at 1. So here we first blind the vendor, so withhold or blind. This is a blind or an inf message to the vendor about this particular transaction, right? So that's the beginning. Now as the second step, we also blind the miner of this double spend transaction. We don't want the miner to mine a block with this double spend transaction because we want to mine the legitimate transaction. So then we send to the network here the double spend transaction and the legitimate transaction. We send it to the weak miner. So we want the weak miner basically to create a block that contains the legitimate transaction, right? Because we want to forward this legitimate transaction later to the vendor so that the vendor accepts the transaction. But the double spend transaction should be mined by the Bitcoin network, and we hope that the Bitcoin network will maintain the main chain containing this particular double spend transaction. So let's restart, right? So we blind the victim from the double spend transaction. Then we blind the vendor from the double spend transaction. We send the double spend transaction to the Bitcoin network, and then we send the legitimate transaction here to the weak miner, right, in step 4. Now in step 5, the Bitcoin network, because it's probably has a bigger hash rate than the weak miner we're working with, it will mine block BD, and the adversary will receive block BD in step 6. Now we have to make sure that the vendor and the weak miner are not made aware of this particular block. So to do so, we send the hash in step 7 to the vendor, and in step 8 we send the hash to the weak miner. So we kind of try to blind the vendor and the weak miner from this block BD. And then in step number 9, finally the weak miner finds a block with the transaction, with the legitimate transaction included. And then the adversary will receive this block BL, and finally in the last step he will actually send the block with the legitimate transaction to the vendor. And at that step right here, basically in 12, the vendor will say thank you, here are the goods, right? That you can basically, because he has this one confirmation transaction included in a block, and he's happy. Now, what will happen afterwards is that the Bitcoin network has probably a hash rate that is quite a bit larger than the weak miner. So if you look at this in terms of block length, so what we actually did here, we created a fork. So this is the block D, and this is the block L. And then it's likely, because the Bitcoin network here is faster, then it's likely that this will basically be deprecated, because the Bitcoin network has a higher hashing power. Now, what we've done here is we've shown that you can actually do this kind of double spending if you collaborate with a weak miner. I mean, there are a few assumptions. For example, there's the assumption that there is no kind of a fiber network, right? There's no like direct connection between the miners. So we assume there's no such thing, right? This doesn't exist, which might be a strong assumption, because the miners have an incentive to connect to each other, to exchange information, to not be eclipsed, right? They want to have the best possible diversification, I would say, in terms of information gathering. But at this point in time, here, because of this chain, the vendor is basically defrauded, and the double spend worked properly. Now, I mentioned end spending attacks, and this can be done. You can have a vendor 1, you can have a vendor 2, vendor 3, etc. And if you do that, you can use the same block or the same double spend attack against multiple vendors, and therefore increase your overall revenue as an adversary. Okay, good.